All right, we're back with another project here. So this one, way more complex. We have a multi-site enterprise design here. So we have four different areas. Well, technically five here, right? We have two branches, two regular office branches. We have the two C routers, a carrier router in the center, and HQ area, and a data center, right? So essentially, this whole topology is essentially we have our HQ where our actual headquarters or the network is, right? We have DHCP running here, and we have just mainly like other departments and stuff like that configured. We have the data center where it's hosting like our DNS server, web server, OA server, and that's has two firewalls for redundancy. And then in the middle, we have the carrier where all it's connecting to everything together, and it's connecting all these links together. And that's actually the gateway to actually get into the actual internet, which is this router over here. And then we have two branches here, two office branches here. So just it seems like two buildings off in like the distance, like two other like areas. So let's say this one would be Chicago and this one say New York, for instance. So yeah, right. Just like the last one, I do have uh the config or the mop here, so of how to do everything here. So I'll just go as we. I'll just explain as we go. So now I'm not. I'm gonna come back to this right here, but let's just start with the HQ, right? So the HQ, yeah, we have six VLANs that we're creating here. We have the engineering, marketing, sales, admin, finance, and guest. So VLAN 10, 20, 30, 40, 50, 60, respectively. Every single all these switches have it, and it's also the same for these two branches, which I will mention, which I will show you. But if I were to just show you right real quick, I'm able to get a DHCP on all of these. Yep, one right here. I could get a DHCP on this one right here. There you go. And I can just print over here, right? Force it. Oh wait, right. Let me actually just see there. These are all can get IP address. There you go. See, all these can get IP addresses. These ones right over here. I you can ping the uh server. It'll take a minute. It's because of the firewall. Because it was working. There you go. See, we have a ping right here. It is kind of inconsistent, and that's because of these two firewalls. This one's not configured, but this is for just the sake of the lab, right? But we are getting ping. So, uh, for HQ, we have six VLANs, right? And and with both of these switches, I basically have switch port mode access and switch access VLAN, like the PC. So they actually have the name that's department, marketing department, sales, and you can add more PCs here. If you really wanted to, you can add. But we also have trunk ports to the actual layer D switches here, and this is the same thing done for LS4, LS4, this one, and we also have spanning tree as rapid PBST per VLAN spanning tree, Cisco's proprietary running all of these, right? We have the LS1 as being and as the primary spanning tree bridge, and we have the other one being the secondary, right? And we also have HSRP, which is I believe is hot standby router protocol. If I've said that correctly. Essentially, we have uh we have the capabilities for one of them to take over if one of the layer three switches fail. So within this interface VLAN 10, we have it as that was people. We have 10.1 as being the IP address. The other one is going to be 10.3, and we actually have the standbys as 2.444, which is the one that's not actually active, and we have same thing on the other side. So one that's going to be active is not going to use this IP address, but when one does go down, it does use it, right? So how to all right, so the command here is show standby. We have VLAN 10, group 10, state is active. If we go to another switch, it should be on should be on standby. Yep, standby. So one is ready to actually take over if the other one fails. That's basically right. Priority. So basically, the higher the number, the higher the priority. So essentially, this is on 110 is the one that's active. 100 is the least prioritized. So that's why the LS 3. By the way, this is LS1 and this is LS2. LS1 the player 3 switch here is active, and the other one is standby. Right. So it has higher priority than the other one. That's why have basically entered in VLAN routing just already here. So that's that. The HCP server, we have basically actually this is I don't even have this here. This is only not even this is actually on a V. The servers are actually on a VLAN as admin, and I just have it just that way. But DHCP server, so basically we just have it as dot 40.3 dot 4. Yep. The gateway is being dot 3 1 and 3, right? And that's essentially uh IP addresses for the DHCP servers, right? The pools is very simple, very simplistic. So we have it's 172. We're using an address of 172.16, right? The next number, which is basically the next octet, we just have that as a VLAN number. So 10, 20, 30, 40, 56, doesn't matter. It's there. So VLAN 10, obviously, it's going to be 172.16.10 dot whatever number, right? So VLAN 10, we just have it by 10.10. And I can show you the pools real quick. Pools here. So we have it 10.10 as being the starter, 10.1 obviously being by the layer 3 switch. And yeah, done. And we just do that for every single of these VLANs. You will notice that we actually do have more of these pools for the other two branches, which I'll explain in a minute. OSPF is running here. I'll go into the router one and I'll show you if I do enable show the OSPF NE. We have full states for both of them. So both of these switches, right? And yeah, we have OSPF running on here. That's about pretty much it. Port channels also ran here, so between both of these links, so that's why I have bandwidth from 1000 this. Uh, BGP is also enabled here. BGP is enabled completely here. We have basically IBGP was between the carrier and the internet, and EBGP for the all the other. So essentially, 65001, which is right here. The numbers are here. So 65001, 65003, 50000, 65004, 65002. So these are basically the asynchronous numbers for each branches or each of these zones, right? And this is basically the config. We're advertising both at 16 and 10, right? The 10 network is being this, right? And between this, so this the carrier router here is having dot two. It's being seconding all the subnets between R4, R3, R2, R1 because these are actually outer RCE routers. Um, the middle one is just taking dot two, and each of one dot one. So R1 is gonna be 10.0.1.2. The other one, R2 is gonna be 10.0.2.2. The R3 will be 10.0.3.2, and then the last one R4 will be 10.0.4.2, and then the like CE ones will be dot one, right? That's just I'll show you by via uh here dot one, right? BGP is running on all of these, and we basically have it as remote as over here is advertising, and we do redistribute OSPF here, right? NAT is running here where we are actually connected to the actual internet router, or we have it IP NAT set to inside for this interface over here, and outside for this interface. And we do have a access list where we just set it to the interface, permitting 16, 17, 18. And you might be wondering, wait, what's the 172.17 network for, or the dot 18 for? It's for these two branches. So these two branches are dot 17. So I'm probably let XX. This one is 172.18.x, right? We have both of these networks over here as these different ones. Differentiate between the HQ, which this one is being 172.16x, and that's it. 18 and the 16, 17, 18. And basically, we're just permitting it always any of these IP addresses, any of these VLANs, just to be able to use NAT. That right? Branch one, we're just again confirming the VLANs. We already throw all the same VLANs here, so I threw all of them just in case if you wanted to actually add more computers, right? And like let's say, we have admin, marketing, sales. Let's say you wanted to add what engineering, you could. Um, just would need to set up the encap part, encapsulation 802.1 Q tagging for this. But we go back down here, right? So basically, we have the VLAN tagging here set up properly, and okay to the router. So this right here this right here is a router on a stick, a mini router on a stick here. So and this is just a regular layer 3. So this done all the internal VLAN router is done all in one device. Other ones here around on the stick is just done on two separate devices. The routing be done on the router in this case. So yeah, we have BGP ran over here with the network here, and DHCP also with the relay address because you need actual helper address so they can find a DHCP, right? And I showcase that we can't find a DHCP, right? Again, Rapid PBST is running on here as well, and it's the same exact thing. The only difference is that we're just changing the network from 17 to 18. That's it, right? Um, I don't know if I can show you by show. Well, we do have notifications right here. So neighbor, 10.4.1, 2.1, 3.1, up. So as you can see, all four of these CE routers are up. So yeah, right. That's about it. The data center, we have basically three VLANs. One for the DNS, web, and OA. Very simple, very simplistic. This one is the 8.8.8. One is 3.3.1, and this one's 5.5.5.1. We have static routes running throughout here because, and actually, in this case, OSPF or any of that stuff is not really necessary for this. The only reason why, because this is not something that's going to be changing. This is not something that's going to be changing. Um, because servers are like you set an IP address or a stack, give it an IP address that manually set it, and just forget it, right? So this right here, you really just set it up once and forget it. That's it, right? So we have essentially the IP address is set here for all of these, for both of these switches. Again, here 8.8.8, 5.5 slash something for Sentinel, 8.8.1 as a gateway. Here are is set up same way of this. 254 just taking the last available IP address, and that's about it. We have routes for the layer 3 switch just here to talk to these two firewalls, right? And then BGP done on the router here. And with the and the R2 and R2 also having the IP addresses firewall to the router, right? And then again, forwarding all any traffic to the main carrier router, right? And then with the carrier router, we're able to just have all of these just point to point to the firewalls. That's about it. The firewalls just have IP addresses set here. So this one's 10.0.21.2. So this one is set to the router. 20.2 is the one set to the layer 3 switch. Do the same thing for the other one. And then the access list. So this essentially in the firewall I have to do ACL for this. I'm just preventing all 60, 17, 18 networks and even the 2021 because this one wasn't allowed to be ping and just deny anything else. That's really just it. Basically, I'm just allowing it to prevent and then deny everything else outside that. And then all the routes here that's allowed here. So anything outside that's any of these address goes to this, and then anything inside this. That's about really just it. And obviously putting the access list into the actual interface outside. But that's about the bit about the whole project. This right here this one is probably one of my favorite ones. Also, to comment, so for over here, this is about basically adding the network masks. This is like basically the more specific route of the network that we're advertising, and this is for BGP. Um, I would say if you do have an error, if you are trying to do this, just remember R1 for layer 3 switch. Layer 3 switch because you need to keep in mind the return path. The layer 3 switch is not gonna know how to get back, so you will need to do a redistribute BGP of the actual asynchronous number 65001, which is the two in the subnets. So because it will show you in these routes. I can actually show you the route. Basically, it'll basically take all the BGP ones that it learns and just submit it to the layer 3 switch. So now it knows that if I'm trying to get an IP address right to this other branch over here, right, and uh and like it's obviously not in our network because it's gonna know that it's gonna send it to the router and it's gonna send it to the carrier and then it's gonna send it to the. I can do a simulation real quick. At TV request. Traveling. It went from R1 to LS2 to LSW, and then it goes to LS1, and then you can see it's taking multiple, and then it sends to the HTTP server LS1 to R1, then to straight to the router or the carrier router here, and then sends back to it. Boom. And this is and right now it's just doing the whole Doro process. So discover, offer, request, acknowledge. So yeah, and if we go check again, successful. So that's about it. Um, yeah, that's about it. That's about pretty much how this is. I will again be putting this in Basebid. And yeah, yeah.